Hey guys, it's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to rewrite expressions using properties of exponents. Now, this video is a little bit different. I'm going to talk a little bit about mathematical definitions and provide some concrete examples, and then the following videos are going to be more challenging types of problems. As far as key concepts, there's a number of different properties we have to go through. I'm not expecting you to know them by name. I'm just going to introduce them by name and then kind of go through, as I said, definition and example. But first, let's establish that if I use A and B, I'm talking about any real number. If I'm using M and N as my variables here, they're going to be integers, so any negative or positive whole number. Now the first property I'm going to discuss is going to be the zero exponent property, and that tells us that anything raised to the zero power is equal to 1. Literally, anything. So we could have something like 5 to the 0, well, that's equal to 1. We could have something like x to the 0, well, that's also equal to 1. So literally, if you're raising any base to the 0 power, it simplifies to 1. Next is the product of powers. That tells us that if we have some base raised to some power multiplied by that same base to another power, we can combine these by adding the powers together. And here's our example. We could have x to the 4th times x to the 6th, which gives us x to the 4th plus 6, or x to the 10th power. And here's how it works. X to the 4th means that there are 4 x's. X to the 6th means that there are 6 x's. Now, if we're multiplying these two quantities together, how many total x's are there? I'll give you a hint. If you said 10, you're correct. Now, quotient of a power. Quotient is a mathematical term that we use to describe division. So mathematically, we'll have a to the m divided by a to the n. Notice that we still have the same base. We're talking about simplifying by subtracting the top power minus the bottom power. And here's our example. We could have something like p to the 7th divided by p to the 2nd. This would be equal to, how many p's are on top? Well, there's 7 of them. 1, 2, 3, 4, 5, 6, 7. And on the bottom we have 2 of them. We can start simplifying p, so p divided by p is 1. P divided by p is 1. How many total p's are left? Well, p to the 5th. There are 5 of them. Next we have power of a power. Now, power of a power tells us that if we have some base raised to a power, and then we raise that to a power, we are going to be multiplying these two exponents together. So if we had something like 2 to the 3rd power raised to the 2nd, this could also be written as 2 to the 3 times 2, or 2 to the 6th power, and when we simplify it, we get 64. Cool, right? Alright, power of a product. Now product here is your key term here. Product means that we're going to be multiplying two different quantities together. So in that case, we'll have something like a times b. But what if we raised it to some power? we would raise each individual term inside that parentheses to the same power. So if we had something like 4x to the power of 3, we'll be raising each individual term in the parentheses to that power. So this becomes 4 to the third times x to the third, and when we simplify, this could be 64x cubed. Okay, almost done. Power of a quotient. So very similar to the power of a product, but we're talking quotient now, which is a division. So if we have a divided by b raised to the m, this actually turns out to be a to the m power divided by b to the m power. Our example for this, we'll use x divided by y. All of that raised to the 5th power. This actually becomes x to the 5th divided by y to the 5th. Last but not least, I'll show two definitions and two different examples here. We have the negative exponent power. So that's telling us, like, what if we had a to the negative m power? Well, we can write the reciprocal, and then your power becomes positive. Or the other way around, we could say, what if we had 1 over a to the negative m? Again, reciprocal. We're going to have a to the m power. Here's two examples. We could have something like 4 to the negative 3rd power, which is going to be 1 over 4 to the positive 3rd. Notice we changed the sign. This simplifies to 1 over 64. Second example we could have something like 1 over 2 to the negative 2nd. We're going to flip your fraction, and your power becomes positive. This becomes 4. And that's it.